What's up, YouTube? Another edition of ManCave Astronomy, hanging out here in the man cave. We are doing collimation, and I just figured I'd share some things with you. I've already got the scope collimated. I did a video of me actually going through some of the processes and different things, and in the light of going back and deleting outtakes and different things when I was getting ready to put it on YouTube, I realized I deleted my first video. So I'm going to make just a quick video. Hopefully it's not going to be too awful long on basically everything that I've done and some of the little issues that I kind of overcome to get this scope pretty well collimated. So basically the first thing we did was we took, and the process basically, it was fairly simple. I did some reading and some different stuff online, and if you have any of the Farpoint stuff, or the auto collimator really, they've got a website that they really go in some pretty good in-depth, and I did a lot of reading on. I'll give you the website. It's http //tinyurl tinyurl .com /8xchsq5, and that should take you to a astronomy forum where Farpoint has put a big thread on about doing the collimation and pictures and diagrams and everything else. So anyway, basically reading through the little pamphlets that come with the stuff and doing some reading and some YouTube looking, basically what we done was we took we started out, we did our center spotting, cleaned our mirror, put the scope all back together. Then we put the construction paper in the scope and at the primary where the mirror was removed, and we adjusted our secondary mirror as best as we could by the naked eye, and got that centered up and nice and aligned, and everything. So we got all that done. The next step we did was we put the 2-inch Cheshire, we put the Cheshire in, and we aligned the reflective circle with the triangle, the center spot. We aligned those so we got our primary somewhat facing the secondary and aligned with the focuser. So we kind of did a rough alignment of all that. Next we put the single point laser collimator in, and we adjusted the secondary to get the secondary kind of somewhat in the neighborhood of the primary alignment. And like I said, we just put the center spot of the laser on the center spot, and then we went to and there were several times in between. At this point, when you put the single point laser collimator in and you do an adjustment there and you get it centered up, you go back to your Cheshire and you fine tweak the triangle and the reflective donut, and then you go back to the single point collimator, and so on and so on and so on and so on until you pretty much you'll kind of come to the same conclusion I did, where either you've got a lot of play in your focuser, or you can sit there for weeks and tweak those things, and you'll never probably get them just spot on, perfectly. And I worked on it and worked on it and worked on it. I've been messing with this thing for about 6 hours tonight, and basically I got the 2-inch Cheshire where the donut, the reflective donut, and the triangle were pretty well on par. The tips touching the reflective donut, and then the laser pointer was in the same, in this actual center cutout of the triangle. And from there we went to the auto collimator and we put it in. And I'm gonna tell y'all what, that auto collimator, that is one finely tuned piece of equipment, because that thing would just, if you breathed on that focuser, that thing would just, that image would just bounce in and bounce out and shift and do all kinds of crazy stuff. So here in a minute, I'm gonna get the camera out and I'm gonna actually put each piece in and let you see through the scope and see kind of what I was seeing. And one thing that I realized once I got the and probably part of the problem with the 2-inch Cheshire and the single point was I had a ton of play in my focuser, and something that you have to do, not unless you've got a Moonlight focuser, Feather Touch, yada yada yada, some high dollar anything but the standard Meade focuser, you probably are gonna sigh a breathe of relief, because you don't have to worry about the intolerances that the standard focusers have. If you do have a standard focuser, I've got a little solution for you. So hopefully you won't fight and struggle as bad as I did for the first 2 hours of tonight messing around with the auto collimator and the Cheshire and the single point. Like, you know, these things are just all over the place. None of them will line up. Every time I get them lined up, they bounce out. And what I did was I took the take you over here to the scope and I'll show you. Oops, without dropping the camera. Basically what I did was I took the focuser completely apart, looked down the actual focusing housing, and took the draw tube out and to see what kind of, if they had any kind of a spacers or any little shims or just kind of what was down there, and just to kind of try to get an idea of what I could do to tighten up the tube. And what I ended up finding is, and this is on my 10-inch, you know, I don't know if the 6 or the 8 has this, but the focusing tube has this focuser lock knob, and that, I would say the 8-inch, this is probably the same focuser that's on the 8. Now the 6, I don't know if this is just a regular knob. You need to take your draw tube out and check, look down your focusing tube and look and see if you've got the same setup that I do. And basically what I found is with the draw tube taken out, is that this set screw actually pushes on a strip of plastic that's housed right here. And I never really messed with it very much, I should say, because let's face it, I didn't have the scope collimated and I wasn't really too worried about it, and putting the eyepieces and things in. But what I did find that actually worked really well for the collimation is I've got this focuser kind of set up now. Is what I did was I put the focuser back together, put the draw tube in, and I tightened this down where I've got a good, really snug fit on. And basically I almost screwed this thing into the point where I just about couldn't even turn it by 2 fingers anymore. And that actually took all the play. I'm not going to say all the play, but I'm going to say it took 95% of the play out of the draw tube and the housing. So now the focuser is now riding on this plastic strip in here, and this actually presses it up into the rack here for the drive, you know, the focuser drive. Now once I got this fairly good and snug, and I just put the little backing plate with the 4 screws here, I just put that down and just very ever so slightly just gave it a little snug so I could feel how much tension I was getting out of this focuser adjusting knob, the lock knob. And as you can see, I mean, I can just barely turn that thing by hand. And then once I got it to a pretty good, and you can see, I mean, it's snug. It's gonna have to be snug. And then what I did was I just kind of, just 2 fingers with the little screwdriver, just snug this down to where it's got a nice good, I can do it with just 2 fingers, and it does move the scope a little bit whenever you adjust this. You know, it's going to be kind of tough to keep focus, or while trying to focus, keep the image stable, which I don't know that you can really do that. I never really could ever keep I had to make a focus adjustment and then give it just a few seconds to let the scope kind of settle, and then, you know, fine tweak, settle, fine tweak. So that's not really a big issue. I kind of had to tighten all this down anyway, because as I start putting these big eyepieces in, and of course hanging the camera off of here, you know, you don't want your draw tube to just start ever so gradually just sliding into the focuser anyway. So I kind of needed to do this, and that saved me about 2 hours worth of headache. Finally kind of figuring that out. You can see it's not bad. You know, you know, it's stiff. It's good and stiff, but it's not to the point where I'm literally just straining here to rack this thing in and out. So while we're talking about the focuser, the other thing that I wanted to just share with you is you need to have the focusing tube about halfway out, about like that, about a good 2 to 3 inches, about 3 fingers worth on the focuser tube, about halfway out, because if you try to, let's face it, not unless, you know, you're a whiz bang with focal rings and everything else, you know, and I'm pretty sure that it's impossible to do, but anyway, you're not ever going to use an eyepiece with the focuser racked all the way in. About the only time your focuser is probably racked all the way in is when you're toting the scope in and out or moving it. And the same way with all the way out. The only, you know, time this thing should be all the way out is when you're just achieving focus past the point of probably comprehension. So anyway, move your focuser in about halfway. That gives you a good bit there for the things to sit in, put a little weight on it, kind of act as an eyepiece. The other thing too, the reason I say that is because when you rack this all the way in, you tighten up with the pinion and the rack, and it actually shifts the focuser just a little bit, because you're putting that downward kind of tension on it. Same way with out, when you rack it all the way out, it almost kind of cocks the draw tube, because you've hit the stop, and you know you're at the end there. So you want mid length on the draw tube for doing your collimation. The first thing we're going to start off with is our 2-inch Cheshire here. We're going to put it in, and the Cheshire actually, even with the click lock, it fits snugly, but as you can see, I mean, I can pull it in and out. It doesn't actually lock in, which doesn't really matter, to be honest with you. I've tried it both ways and I get the same image. So I'm going to center the camera up here as good as I can. I'm going to focus in just a little bit. A little bit too far. Yeah, you can see, I can see that ring there. Alright, and there you can see the triangle is really good and centered in the reflective donut in the Cheshire, and that's what you want. You want to see that. And as I move the camera, the little triangle will kind of move some too. So I'm trying to give you a perfect look down the deal here with the camera. So anyway, you can see the points are touching, or just almost right at touching. It is as close as I can, as far as I can tell from everything that I read and whatnot. I mean, it is just spot on, as far as that goes. So anyway, and then remember your 2-inch Cheshire, you do you do your primary mirror alignment with this. When you're using this, you're going to actually be moving your primary mirror adjusting knobs. So that's what I read in the 4-point pamphlet. So anyway, so you get this thing kind of lined up. One of the other things too, real quick, while we're talking about doing primary alignment, one thing that I did when I did the last series of videos with the centering spot and the cleaning of the primary, I used a slide mic and tried to kind of set a mid-range depth on the mirror. And what ended up happening with me playing with this thing, I lost count of my turns on my screws. And what I ended up doing was I ended up screwing my primary mirror all the way down to the base by these adjusting knobs. Let me back it up here a little bit. By these adjusting knobs, you can see my little marks that I put on there. But what I did was I just tightened these all down, all three of them down, with my keepers backed off, and I pulled the mirror all the way down to where my adjusters were bottomed out with the mirror. And then what I did was I actually gave it about 3 turns each, and that gave me enough to where I can do some mirror movement, but I also kept the mirror far enough back with good spring tension. So that's what I ended up doing there. Like I said, I bottomed out these screws. I screwed them all the way down, and to where my mirror was all the way against the back of the retaining plate. And then I gave it I unscrewed it 3 rounds per screw, and you can see my little white mark. So I counted them, and that gave me pretty much a set point to go from. And it was actually it worked pretty good. It was actually pretty close to being dead on. You know, just a little tweak here and there, and got it dialed in. Now, the next thing we did, just took a swallow of the old brew there, and then we slid the single point. We screwed the single point collimator in, and I always try to use the label to make sure it's oriented in right. And then just a good snug on the quick lock there, nothing overly tight. And the one thing that I did end up finding with this, and this is of course pretty hard for you guys to see with the camera, just the camera doesn't like lasers very much, and you can see the reflections there. I'm going to zoom in to the center spot, and you can see the center spot, the laser is actually just a little bit low in the center spot. The camera exaggerates that a little bit. It's actually not quite that off, just because the camera doesn't pick up the pinpoint on the centering spot. Trying to maybe move this thing around here. You can see as I move the camera around the primary, it almost disappears there. But that spot also changes. But when you look down the tube, you know, we're just a fuzz off. And to be honest with you, if you don't even tighten down the quick lock, you just set the laser in there, and you can see as I kind of tilt it how much that laser moves. So I just give it just a barely even a snug, and that laser is actually pretty close to being on center. And it just depends, you know, like I said, you're gonna have some play. Like my guy said on Astronomy Shed, lasers lie. So that is some truth there to that. See, like right there, it's pretty much spot on. And as I go over here and mess with the quick lock, you can see that thing will jump in and out. So, you know, you just kind of right there, it's almost dead center, but if you actually were looking at it, and it's pretty well centered. But you can sit here and breathe on this thing and it'll jump in and out and move. So the laser is a good reference. Don't bank on it a whole lot. The kind of the sad part about that is that was the most expensive piece of the tool, about $140. So you know, but it is you know, I'm not PO'd or anything. I spent 140 bucks on it because when I'm not using it in the scope, it makes a really good dog little chase toy with the pointer. So you know, I'm not knocking that at all. But I wouldn't focus too much on that single point laser. Use your 2-inch Cheshire. When you do your secondary with your single point laser, your secondary is what you're going to be aligning, and make your adjustments to your secondary, and then put your 2-inch collimator, your 2-inch Cheshire collimator back in. You're going to have to retweak the primary. Go back to your single point, you're going to have to retweak the secondary. And I found that if you get that laser in the center cutout ring of the center spot, the triangle, the punched out hole there, if you just get it in there, then you're pretty much good enough to start using the auto collimator. And we're getting ready to get into that here in just a second, but it takes about 10 times to kind of bounce back and forth between the 2-inch Cheshire, the single point laser collimator, to really get both of them lined up in a good position, to whereas you know, you take things in and out, and move your focuser and touch and poke and prod and kind of see what's going on and make your adjustments. You know, you'll soon to learn that you know, as long as you're in the ballpark, it's pretty close. The auto collimator is the focus of what you're going to do your fine tune with, and I'm going to stick that in and just one click. I mean, that's literally all you do is just one click. And now that I've moved my focuser, I mean, this thing is just so sensitive. It's not even funny, because I can just sit here and just rack in and out, and it changes and jumps around. But you know, there's no way you're gonna have this thing completely, I mean, within a thousandths tolerances of anything. You know, it's gonna have some play in it, and that's just manufacturing. But ultimately what you want to do is, when you put it in, you're going to adjust your secondary mirror, and this is what you ultimately want to accomplish. Let's see if I can get the camera a good angle through here. And what you're going to see is you're going to see a stack of images, and there you'll see you know, 2 or 4 or 6 or whatever of those of your center spot. And what you want to do is adjust that secondary to where you pretty much stack all those images into one single image of that centering spot, and it'll get very crisp and very clear. It'll also get darker as you align your secondary to your primary. Now, what I found the best thing to do is tweak the secondary just a little bit, get your images really close, and then go ahead and take your auto collimator out and put your Cheshire back in, and you're gonna have to readjust just really fine little tweaks. You're gonna have to readjust because you're gonna jump out on your circle and your triangle here, and then you tweak and get that all centered back up. You take this back out, put your Cheshire back, or your auto collimator back in, one click, and you get to where I'm gonna loosen up my quick lock And I'm gonna actually tilt the, if I can get you a good, if I can hold the camera. It's hard to catch the reflections. But you can see there as I move the auto collimator in the quick lock, you can see those reflections bouncing. And like I said, I mean, it's nothing more than, you know, when you lock that thing down, I mean, it can be nothing more than just moving the focuser back and forth some. You know, you can see now that we're back to a solid triangle. You know, that's what you want, is when you go back and forth between the two, you want to end up with the center spot in the donut of the 2-inch Cheshire, and then when you put the auto collimator in, you want a single stack of images as best as you can get. And I mean, it doesn't take nothing to change that reflection in that auto collimator. I mean, just nothing more than taking the little bit of slop out of the gears in the focuser will make that image change. But it does, you know, it does come in and come out a little bit, but you know, you can definitely tell that, you know, the reflection is definitely in line. And as it gets darker, the more you get those two aligned, the reflection gets darker. That's when you know you're getting close too. And like I said, you can put your single point laser back in there. I think you're going to find that it's going to be off. You're still in the center cutout, but you're not dead center. And then if you just simply take and just play with that laser collimator just a little bit, you'll get it back in the center, and everything else will be in center as well. So it's just a kind of a, you know, as you take things in and out, you're not going to put them back in the exact same spot and everything else. But what you do want to find is that everything is pretty close without just nothing more than a breath on something. It jumps into back into alignment, and that's really what you're looking for. The other thing I wanted to say too is when you're using that auto collimator, when you're looking through there, you'll actually see your eye. It's called a pupil reflection, and you'll see a pupil reflection. And what that is you've got that secondary and that primary in line enough where you're actually seeing back through that very itty bitty tiny little hole in the center of that auto collimator, and you can actually see your cornea or your retina in your eyeball, in your pupil. This is why they call it a pupil reflection. But you know you're pretty much dialed in at that point when you can see through that little tiny hole, and you can see your eyeball in the primary reflection, and those 3 triangles or 4 triangles are lined up, stacked. You're pretty well collimated. I don't know how you can get any better without spending thousands of dollars on lasers and everything else. But anyway, I feel good about it. I'm gonna take it out this weekend. It's supposed to be nice, and play with the new camera and my new eyepieces and stuff. And I'm really looking forward to seeing what kind of image quality from the way the scope was before to how it is now. And see what the new Sony camera can do through it. So, you know, when I do, as soon as I do that, I will put up a video and let you guys know how it turned out. And I hope this sheds a little light on doing auto collimation and collimating your Newtonian. And I don't have a combination collimator that's the single point laser with the reflection back through the center in the little target window. I didn't buy one of those just because I just felt good enough about buying the far point stuff that that's the way I wanted to go. And this stuff is good quality stuff, nice stuff. And
I mean, it was, I think that took a lot of the headache out of getting this thing. And I know the scope's aligned after reading what I've read and watching what I've watched. This scope has got to be dialed in as close as it's going to probably get without spending another $500 or $600 on a focuser, and you know, having my primary repolished and all this other crazy mess. So but anyway, that's it for the collimation. I will shoot another video after I take the scope out and bring it back in the next morning. I'm probably gonna put the collimators in and check everything out. I'll do a little video on that just to kind of compare, and just do a little update on how the scope did. So until then, clear skies.